from Nanjing Tech University. My topic here today is parallel plant, a smart system approach for ammonia synthesis plant. Parallel system is a reflection of the real world. For example, if we see an apple, we will think of the concept of apple. If we see a lion, then the word of lion comes into our mind. If we see a flower, we construct the concept of flower. The three words apple, lion, flower are the reflection of certain kind of materials in our mind, the abstract features of those materials. The chemical plant contains intensive information and massive operational parameters. With this big data, expert system approach is difficult to maintain and update new information and change control strategy accordingly. But the development of computation capability and future 5G technology makes it possible to manage and control complex systems such as ammonia plant in a more efficient way. Our strategy is to improve bad from learning good. Let's use students learning for example. It's reasonable to think they will act good from learning good. They will act bad if they learn bad. If we mix bad students with good students, there is a large possibility that some bad students can learn from good students and improve their behavior. So it is our strategy. One big problem that ammonia industry face today is the hydrogen variation. Hydrogen generated from solar energy or wind power is hard to maintain its consistency. How can we improve ammonia production considering this hydrogen variation? Because it is a time series problem, the basic model we can choose are recurrent neural network, RN, long short time memory, LSTM, and gated recurrent unit, GRU. This slide shows typical ammonia synthesis process. Hydrogen and nitrogen are mixed together and fed to the reactor. Reactor effluent gas are chilled and condensed by a group of cooler. The anhydrous ammonia are separated from recycled gas. Recycled gas goes back to recompression with fresh feed gas. Operational data are collected in every minute. Input data of our proposed model include hydrogen feed rate, hydrogen feed pressure, nitrogen feed rate, and so on. The output data is ammonia production. The objective function used here is listed in the table, and the root mean square error is used as evaluation criterion. We propose a hybrid deep learning model to optimize ammonia production based on the operational level. The optimization model is based on encoder and decoder, which are LSTM and GRU, respectively. The encoder and decoder architecture is known as sequence-to-sequence learning. The architecture comprises two submodels that are encoding mapping source and decoding mapping representation. The task of encoder is to read sequences from input features and encode them in a fixed length vector using LSTM cells. The decoder is trained with encoded vector to optimize the output sequence using GRU cells. Compared with other models, the proposed hybrid model has the best performance. The proposed model follows the original curves of the raw data. It almost overlaps the original curve. With the help of proposed deep learning model, we find a better operational pattern that can improve ammonia production by 12%. Tracing to its resource, the improved pattern requires 18% less of hydrogen input, and it requires higher hydrogen pressure. It reduces nitrogen input by 10%. It requires lower nitrogen pressure. The reaction temperature is kept the same. The reactor pressure can be 4% lower. There are limited change for cooler loop inlet temperature. So is cooler loop group outlet temperature. Separate temperatures are almost the same. Recycle rates are almost the same. To sum up, first, the hybrid deep learning model is more accurate to process ammonia synthesis plant. Second, the deep learning model is capable of improving bad from learning good. Last but not the least, the improved operation of an ammonia plant requires 18% less of hydrogen input, 4% less of reaction pressure, but produce 12% more ammonia. Thank you for your attention. If you have any question, please contact me using the listed email address.